All right, we are recording.
Okay, cool.
Let's see. Hopefully the fan is not making too much noise for the microphone. Like before, I was listening to it, what I recorded last time, and it was actually quite clear. Like even just the laptop mic.
Yeah, I thought so too. Okay, so I also forgot to upload still, so I'll do that today.
Yeah, that's fine. But we have the pull request from last week, and I guess we sort of agreed that we're just gonna merge whatever. I think you kind of did some things afterwards. You
Do we want to
completed.
just look at the diff quick?
Yeah.
Right. Oh yeah, so this was interesting on line 9.
Mhm.
Because we had never used Origin before, like it didn't have a compilation error.
Mhm.
But then when I tried to use Origin, it made me do. It said I couldn't use that type of assignment.
Okay.
So then I got a compilation error when I actually tried to use it.
I see.
So that's why I had to change the assignment to the fields X, Y, and Z.
Interesting.
Let's see. This all looks
Right. We started with the array
right.
and the right color. That was already, I think, from previous.
Yeah, this next one I probably should have put somewhere else. Oh no, this is where we're saying right color.
Mm-hmm.
Oh, one thing that I thought was interesting.
Yeah, go back.
Right. Oh, I just kind of refactored this a little bit. But one thing I thought was interesting was, we'd been using that like as syntax here. So another way of doing this is you can take the usize and put it as the type, like be explicit about the type that you want for the variable. So up here, what you'll notice is I do the int from float, but then like I don't have to cast it because like you're setting the type there. So I guess it's another way of like specifying that, but you don't have to do the explicit cast if you just say like it'll like infer what type it needs to be because you've said it needs to be a usize.
Right. Well, honestly, that's one thing that I'm still not totally kind of clear about and comfortable. Like, that was one thing that was a little bit unclear. Like, why do you have these two types of typecasting? I guess that's something I want to look at by myself and just like really understand the reasoning behind it. And
so my high level understanding is that this is potentially, so as this way is it's a safe typecast. Like there's nothing that you're doing in terms of that you could do to lose information.
Okay.
So for instance, if you have a U16 and you say as U8, like that's totally safe because if the U16 is within, or sorry, if you have a U8 and you say as U16, that's a totally safe conversion because
you're just expanding
the number of bits. Versus if you go the opposite way, it's potentially unsafe.
I see.
And so I think they have these utilities for doing that potentially unsafe conversion, but then you still have to be explicit about the data type that you want to convert it to. So this goes float from int, but you could make a float could be a F64, F120. I think in Zig you can do like any number of significant bits or something like that. So the as is like the safe conversion, and the float utilities are sort of these like unsafe, or the built-in functions.
Yeah, this is the guide, so I don't assume there to be big explanation. It's just like a recipe, right? Like, integers and floats may be converted using the built-in functions. Sure.
So float from int is always safe, whereas int from float is detectable illegal behavior if the float value cannot fit in the integer. So, and then it looks like you just have you might get a compile time error or something like that. So, versus, can you look up as? Is that?
Do you think it's gonna be in here?
Can you do the at as? Would that show up? Because it is also at. like when you clicked on the float from int, like scroll down in here,
Mm-hmm.
and went here.
Oh, you want to
possible-
look up? Yeah, go ahead. Didn't know that you want to have it in the
There.
documentation. Built-in functions, performs type.
Performs type conversion.
Coercion, okay.
This cast is allowed when the conversion is unambiguous and safe, and is the preferred way to convert between types. So the other one, I guess, is ambiguous, but in one direction is safe. And this is what I was saying with, I guess they don't give an example, but I'd assume if you had a U16, you could, or U8, you could safely cast that into a U16.
I see. Okay. Well, I mean, that makes sense.
It isn't it like it is a little bit more verbose, but I do appreciate that it's like explicit, like these
Right.
pieces. Yeah. Okay.
Yeah. All right. So that's good.
And then I just finished writing
Did the test. So that that passes, I assume. So let's see. I'll just merge it. Cool. I have some things that I don't have. Oh, this was just okay. Git restore, retracing, source music. Okay, git fetch. Oh, I'm on week 3. Should be week 4. Okay. Already up to date. Okay.
Go to the bottom.
Yeah, that
Yeah,
looks
okay.
like
Looks right.
that looks like it, right? Okay then. Well, in that case, let me just do git switch. Oh, by the way, I did this thing. I didn't have week 4, and I just did git switch without the like C, or was it to like make a new one, and it also worked without it.
So, but did you fetch before that?
I guess I did. Yeah.
Git fetch.
Yeah.
So that, I think that pulls
like-
down the new stuff. But maybe git switch is smart about like, yeah, interesting.
Do you think? Well. Okay, git switch week 5 invalid. Oh yeah. Okay, so something looks weird.
Something that's weird.
No, you're just
Oh
looking.
no. Okay. I'm just open the ray tracing weekend.
Right. Click to restart. Okay, let's do a restart. All right.
It's funny because I think I have auto updates on for Zed and you have auto updates on for Ghosty, but
Right.
we don't, each of us don't
But I
know.
still have to manually.
Do it.
I still have to agree to it, because obviously, like I don't know if you use it. I just started using these like Tmax sessions.
Okay.
And I guess if it would just quit now, I have a bunch of processes that are kind of stuck. Okay then, so I'll call Trevor.
Okay, cool.
And then what did we... So we ended up, we're implementing rays. I guess, yeah, before that it's just about writing the color, which we did kind of refactor to use that fun function. And now it's about implementing array class, which in our case is a struct. And I don't actually remember if we did it all. So, oh yeah,
We have
we
it.
did because we have the test.
So I think we're on 4 point sending rays,
Oh yeah.
shooting a ray. Yeah.
Okay. Right. So like the idea is that you will now sort of simulate. You have an eye position, and you have some, like, as if you have the screen in front of you, and then you will compute like the rays that are shooting from your position to the different points kind of sampled across the virtual screen that you would have.
Okay.
And the thing that they're starting with is determining the aspect ratio.
When first developing a ray tracer, I always do a simple camera for getting the code up and running. Okay. I've often gotten into trouble using square images for debugging because I okay, so you want to make sure you have different width and height just so that you make sure that your coordinate space is different.
Right. I mean, I was looking at this, I think, some days ago, but I'm totally not clear about what. Okay, so obviously you choose an aspect ratio, 16:9. Looks pretty fine to me. So you can just type it like this. I guess we'll have some, yeah. Then you set an image width, and from the width, you calculate the height. Okay.
Makes sense.
That's what it does. I see.
So you pick a width, and then you first pick an aspect ratio, then you pick a width, and then you just get an automatic height.
Yeah.
Okay.
I mean, it's going to be a little bit interesting for us because we have to do the typecasting. But where do we put it? I guess in the main for now.
So up here.
I see.
I think we have our image width.
Oh, yeah, true.
Yeah. I don't know if you just want to copy that in and we can start.
Yeah.
Okay. So let's see. So the first thing we're going to have is const aspect ratio. And then maybe we can bring up the image width. Replace this with 100.
Yeah, let's put it like this.
Const image height equals, and so we're going to do at float to int. Right? Yes.
I guess, yeah. Is it float to int or int from float? Int from float. Right, and here you want to.
I think this might actually be float. Because I think I remember it was like whatever the numerator was, decides what the type of the.
But then I guess you want to hear the width, no?
Yes, and then what? So this is what I was thinking now. If we do int from float, we want this to also be u size. Is it u size?
I think it's u for the.
U size.
Good question.
It's
so
up here on
basic types. U size?
Yeah, on line here. These are. U size is whatever your like system size is, I think.
Unsigned int. Okay. Variables, types, primitive types.
Calculate the image height and ensure it's at least 1. So I guess we could use a var here. If image height less than 1. Wait.
It's the type of safeguard that I don't know if you like need from the beginning.
Okay.
When would that happen? Like, yeah.
I guess.
Yeah. And then, what is the other code?
It looks like we
doing
viewport height.
Viewport widths less than 1 are okay since they are real valued.
So is this getting into the camera now or no? Not yet.
I'm not catching it actually. So you have the image height. Okay, so I'm not sure if I understand what's the difference between an. Okay, so image is like what you get in the end, like the pixels by pixels. But then they have also, in addition to setting up the pixel dimension of the rendered image, we also need to set up a virtual viewport through which to pass our scene of rays. Oh, okay. So this is just like some abstract viewport that you kind of imagine that you will. Oh, I see. It's sort of the difference between in OpenGL coordinate systems. You have this thing where you have these different coordinate systems. So you end up with like if we are going like backwards, the screen space would be something that's in the actual screen space. I guess this screen space, like in the pixels, that would be what we now just defined. But then you have that viewport also, where it's typically just done as like a size of like 1 and 1, 0 to 1, something like that. Although here it doesn't really make I think it's just because the math is now like simpler if you just have it. Maybe that's what they mean by having a simple camera. Like, but I'm not sure why you start with 2. Like viewport height is 2. We'll choose an arbitrary viewport height of 2. Well, I guess we can just copy it as is.
Sure.
Gotcha. So should I try it?
Yes, we could
What
try
was the shortcut?
I think it's just zig build run. Oh, Command J.
Okay.
Zig
build run.
Oh,
I need
CD.
to right.
Okay.
Unused local constant viewport.
Oh.
Oh, okay. I'll just.
I guess we can just go here. I'm gonna try it.
Right, sure.
Okay.
Incompatible
Type.
What? Well, this is in.
Pixel color. Let's see. Maybe it wasn't. Maybe we didn't have a U. Maybe these weren't. Was there a U32 before? We could try it for I32.
How? Oh.
I'm wondering.
Oh, it's about the height.
Yeah.
Okay.
Expected type use. Okay, so no, they are supposed to be use size.
It's just. Okay. Okay, so this is this, right?
It's saying incompatible types.
Oh, wait. This wraps around just this. So then this gives you float 32, but the image width are a new size. Don't.
Oh, I might have actually broken it. Okay, wait. GitHub.com. H. Maybe I accidentally broke it.
That's fine.
Let's go look at the Git history. We can go back. Or in the pull request. I thought. See, that's what was interesting is that like, it's not even like I think that's what I found out with this is that sometimes Zig doesn't enforce things if it's not like in the
If it's
compile
not
path,
used, oh.
which I guess I found surprising.
Mm-hmm.
So let's see.
That's totally, yeah. You kind of assume that it will just.
Okay, so if I copy this,
But what was the difference? Do you
So-
see anything?
as f32 float from int image width -1.
That looks the same.
It looks the same. I guess what I'll do is I can just try copying it in.
Mm-hmm.
You can see. So here we can. GUI.
That's the same error, right?
Yeah.
How did we have the window size defined before?
Up high.
And
Here.
That was just
They
type
weren't.
inferred.
Yeah. What if we got rid of the types? I think this won't compile now because. Right. Okay. And now we're gonna have this error, but is it just for the height?
It looks like it's just for the height, right?
Hmm.
So this is okay. But height is being problematic. Int from float. So it gives you float. There's no other transformation of it.
I'll try that. I just tried doing wrapping.
Mm-hmm.
Okay. So I just,
I saw.
for whatever reason. Okay, I'm gonna open up the Z-ray tracing. I'm just curious what the types are.
Mm-hmm. Oh yeah, you're opening it in Zig too. In Vim.
Right. So a comp time. See, I think what, like, if I were to make this a U size.
Mm-hmm. It would also break.
Well,
Would it?
and now this is a comp. This is a U size.
Uh-huh.
But then it's interesting because now this is a comp time
Int.
use. So I'm
Mhm.
curious if like maybe in different contexts it like can be compiled to something else. Like
Can you use just like comp time int as a type? That would look weird now.
okay, blocks of code may be forcibly execute a comp using comp time keyword. Integer literals of the type comp time int. Integer literals are of the type comp time int. These are special in that they have no size. They cannot be used at runtime, and they have arbitrary precision. Comp time int values coerce to any integer type that can hold them. They also coerce to floats. Character literals are of this type. So I'm curious, like, the dividing, like, maybe there's a certain type of int you can divide floating point with. Like, sig floating point division. Like, actually, here, I'm curious if, okay, let's try this.
Mm-hmm.
Is there a zig size? Yeah, like I'm wondering if we used a sign. Okay, so if I go back here, and we can just try it with just image, right? We could do
Mm-hmm.
eye size,
Mm-hmm.
and then let's try that. So
Just run it.
what I'm curious about is if
That
okay,
looks to be working.
so and now I think if we were to do this, okay, try it again.
Mm-hmm.
And does that not break again? Interesting.
Expect found e size. That's for height, okay?
Okay, so I'd say we just leave it what we had working. My understanding is that you can't do floating point division with an unsigned integer. It can be done with a signed integer.
Mm.
And my understanding of this comp time thing is that it can take on multiple types in the way that it's used, because it can be because it's a literal, right?
Mm-hmm.
So here it's like a constant that they can compile maybe multiple versions of that in
Mm-hmm.
the different context. But here, this is the result of a computation,
Mm-hmm.
and it has to be a type because it's only at runtime.
Mm-hmm.
I'd actually be curious if you could do like comp time. How do you do comp time?
Maybe in a guide. What is the comp time?
Yeah, so I wonder if you do comp, if we were to run what I just saved, does that work?
It
Okay.
does.
So now I'm curious if we remove the U size, if now we'll get a comp time in.
We get a error.
Okay, try this.
Still, variable of type must be const or comp time.
Okay, wait. So because let's try that. Cool. Okay. So I guess we could even have like a check. You could maybe even do like a comp time check where you say it can't be less than something like that. But now I think down here we could. So now if you run this, I think this should work.
Zig build run. Looks
Cool.
to be.
Okay, so we learned that we can actually do some arithmetic before compilation to turn image height into a compile time int. And so it has those nice properties that like the literal has. But it means that when we compile, we do this arithmetic and stuff. So
I see.
That's
I mean,
kinda cool.
yeah. Well, that makes sense because
Yeah.
it doesn't change, but it still seems like one of the things that you have to sort of the new thing that
Yes.
everybody sort of, oh, that's pretty nice feature, but you have to wrap your head around it. So, and I'm also maybe instead of just like const, can you do like, where does the comp time keyword come?
I think
Like where can you put it? Can you put it like instead of the const, or
I don't think so. My understanding, it's like on the left side of, so that's for a
function? Yeah, I see.
Or no, that looks even like a type almost.
Right, so it's a part of a type. It's just like, to me, this sounds sort of out of some pattern.
Like here, I wonder. So if in this block, here, so.
But yeah, it is like in one of these primitive types. Like comp time int is a primitive type.
Like, does this work?
Or
Like, so I'm just curious.
it does not. Expected integer type found void. Where did you change?
Why? So up on line, I turned this into a block, and like I was trying to see, because I noticed in here that there is this comp time.
Well, the thing is, it could have also changed.
Yeah. Okay, let's just go back to, we can venture down that later,
Yeah.
but we can go back to using what we learned about, I think what we've kind of learned about comp time, which is that we can we can still do arithmetic. Like, it's quite nice, right? That you could, like, I wonder if you could even do, like, comp time. Or maybe that's even, like, automatic to do something like this. Because ultimately, you don't really want to do that computation
at runtime.
runtime.
Yeah.
And you could, like, just put in the binary, like, the
Right.
value itself.
Yeah.
Which seems useful. And I think, like, LLVM or, like, these optimizers will actually just do that often. But, like, it's cool that, like, you can do it arbitrarily complex with sort of the I think it's an open issue specifically for Zig. So okay,
because that essentially really helped us to figure it out,
to hover
and, like, know the type.
Yeah, I think I can share the
Inlay hints, could it
so
be?
inlay hints are not the hover. Inlay hints are, like, you get your code just shows them all the time, the types. The hover is, like, some other Zig, ZLS, Z. This is funny as a Google search.
I mean, this is closed.
But in Z, right? Yeah. I don't think so. Inlay hints are supported, but for languages that support them. So I don't think that it's.
I see. Mm-hmm.
Like, if we looked at the issues and I took the Zig issues. Yeah. Autocomplete not working for the. Oh, interesting. Oh, so yeah, so you see.
These are the inlays.
This is in VS Code that's showing up.
Oh, okay.
And oh my gosh, clicking the wrong thing.
What was that? It's an image.
But then, yeah, in Z, there's nothing so far. So it seems like it's just an issue that's getting tracked.
Gotcha. All right. Cool. So, well, that's one thing.
Okay, so we've got that, and now I commented out this stuff.
So there was the viewport computation, kind of the abstract one. Should that work? Maybe you need to also.
Well, now we're not using the.
Unused local. Okay, gotcha. So, going back to the book. So let's see, what are you gonna do with it? Okay. If you're wondering why we don't here just use aspect ratio when commuting, it's because the value.
Looks like they have a nice figure for what you're just talking about.
Yeah. Yeah, I don't know if we want to read through this. I mean, there's this nuance about why don't we use aspect ratio that you computed above when computing viewport width, right? Because there's this kind of doubling of the code, yeah. Right, I guess it's about. Yeah, I guess this is just some, like, precision thing, no?
Yes. Wait, because the value set for is the ideal ratio. It might not be the actual ratio between image width and image height, right? Because we had that. Yeah, exactly. Precision.
Because that, like, oh yeah, because pixels, like, the pixel size is gonna be in integers, while this has height like 2, and then you're gonna have that, like, the samples are gonna be at specific positions that will have higher resolution, like they don't have to line up to integers. That's
And
my like very layman understanding.
And we had this before he had this block which said if this is less than 1, make it 1, which would change the aspect ratio, right? So
yeah,
I guess it's just to accommodate that it might not be exactly aspect ratio.
Okay, but anyway, like you have the image dimensions, and we have the viewport dimensions. So like height is 2 and width is gonna be 16 to 9 times 2. Is it times or 3.5? Yeah, something like that. So that's what we have. And now next we'll define a camera center, a point in 3D space from which all seen rays will originate. The vector from the camera center will be orthogonal vector to the viewport. We'll initially set the distance, set the distance between the viewport and the camera point to be 1 unit. This distance is often referred to as focal length. Okay, so of course, like the camera center will be at 0, 0, 0. We'll also have the axis. Oh yeah, this is like everybody's always doing these like
The finger gun.
Finger gun thingy.
For Z, right? That's the thing, is like you have X, Y, and then you need like
exactly
right-handed rule.
So this is right-handed. Okay. Because it's sort of like any way you have it. So like I guess thumb is the X, middle finger is Y, and then Z is the index. Gotcha. Now the inevitably tricky part. Well, I guess we can do like camera position. I don't know, probably I'm skipping ahead, but like we have to wrap up soon anyway. So camera position will be a vector. How did we do it? How can
is this going to, I mean, we have a different class that's called, or struct that's called point. Do we use it for?
Point. Right, so it's like point, is it 0.3? 0.3 dot init.
I think origin, because it's going to be 0.
Oh, I see.
I guess it doesn't really matter. But
true. So we'll have that. And the tricky part is, what is the tricky part?
So we have
3D sphere.
understanding this figure.
Yeah, it's just about that you have to flip the y coordinate.
Because of our coordinate system?
Yeah, but I mean, I still don't, as we scan our image, we will start, it's just like, to compute the samples, I guess it helps you to have in mind this sort of window, grid-like 2D coordinate system, where the convention typically is that the X is the same, but Y goes from top to bottom. And so you have to make that kind of switch, I guess. So while our 3D space has the conventions above, this conflicts with our image coordinates, where we want to have the 0th pixel in the top left and work our way down to the last pixel at the bottom right. This means that our image coordinate y-axis is inverted. So as we scan our image, we will start in the upper left corner, scan left to right across each row. Help navigate, we'll use a vector from the left edge to the right edge.
So that's VU.
Yeah.
And a vector from the upper edge to the lower.
It's just like to give you some like I and J in some loop. our pixel grid will be inset from the viewport edges by half the pixel to pixel distance. This way,
Okay.
right.
So it's just so that you have a dot in the middle of each pixel. Like
Yeah, true.
grid makes up, those
Exactly.
quadrants make up P00.
Did we define the pixel to pixel distance? Not yet,
I don't
right?
think so, no.
Yeah. Display is evenly divided. In this figure, we have to, okay, yeah, that makes sense. Drawing from all. Right. This does seem like something for the next time.
Yeah. That's fine. I'm thinking, I mean, in the remaining time today, we could try to move vec. So do you see how in his code he has like a separate file for array and vec?
Mm-hmm.
We could maybe try to move, just like refactor the code and say we have
that
a
makes
vec,
sense.
and then we'd learn just that. Hopefully it's just copying and pasting code, but
True. Okay, so let me do it. So I'll make a new file. Is it gonna be vec3.zig?
yeah. And then I'm thinking it's going to be called like zig modules.
Const vec. Yeah, I guess it's a question if this is gonna be like the STD is almost like this library, but here you're just looking at a local file, so I don't know if the notation is gonna be different.
I'm looking here and it looks like you add .zig, like it's the file name.
Mm-hmm.
I don't know if dir name comes in, but we can just try.
And do you have to do like you're including a scope or like a namespace, or is it just?
So I think it'll end up being now vec. And so I think you can do dot. It depends. So you could do dot vec3, and then you could name that vec3. Like, I think that would work. We could try.
Yeah.
We might get like a unused thing.
Mm-hmm.
Yeah. Okay. So let's just go.
Right. Yeah.
Comment out the unused stuff that we had. So I'm gonna just put like a to do, and say next week.
We could even just output it to the error. But yeah, sure.
6. Okay.
Gotcha. What do we have? Undeclared. Use of undeclared.
So in vec3 we need to also include the import for std.
Oh, did you see it was? Oh, I see. Yeah. So it was const std equals at import std.
Yeah.
Without the zig. Right. Is not marked as pub. Oh yeah, that's what I was thinking.
So now do we do? Is it like pub struct? Pub. Yes.
Yeah.
I think no. At the beginning of the line, so
okay.
It's pub const.
Yeah, that kind of makes better sense.
Okay, cool.
Nice. It wasn't that painful.
No, that's I
like
had a much harder time with Rust modules.
Yeah, like the pub to just like as an export, because I guess you also, I mean, in C+ in C ecosystem you don't have it across, like if you're just compiling your own, but you do have that concept of just you have to export your things that you want to import.
And I'm curious, I guess we can, I'm just gonna move the tests for vec into vec. And then I can go here. And we can maybe even make, I don't know how much we want to break this up, but we could move like Ray.
Yeah, I
Feels
was
it.
thinking we can make definitely utils for right color.
Yeah. Think.
But yeah, I think I'll have to wrap up because I have to find a room for
fine.
the next meeting.
I think that's a
So,
nice way to
that
end.
was
Can you run
nice.
zig format and like we can?
Is
It's
it just
FMT and
FMT?
then source. I think you have to point to the files.
Just the folder is enough?
Can you do? Yeah, does that work?
I should have
It's
made
okay.
a commit before.
I think it's fine.
Okay, so we edit this. Does it look formatted?
Mm-hmm.
It does.
Yeah.
Yeah. Right, let's just see. What was it? We mainly just did.
Aspect ratio. I guess we.
Yeah.
I would say we like learned about comp time. We could even say refactor. The main thing we did was refactor. Like move.
Image size, image and viewport size, refactor. That's good enough for me.
Perfect.
Let's just push it for now, and if we want to do anything like in between, yeah, I guess we can still do some bits of improvement on the PR.
Yeah, looks good.
Cool. Nice.
Short and sweet.